Alright, how's it going? My name is Brandon Fairchild and I'll be running you through my Fluent simulation today. Unfortunately, because of restrictions on my computer, I cannot run the program and record it at the same time. Otherwise, the program kept crashing. So I'm just going to run you through what I did to do my flow analysis here. So right here, I just made an example one. Starting out, you'll just right click on here on the geometry. And you're going to edit the geometry and design modeler. So I have that pulled up here. And the way I did this is you'll click here, go to sketching, click on my line, and I would start from drawing the line out from the origin, out on the horizontal line, and then from the end of the horizontal line, I'm going to make a line going upwards at roughly a 30-degree angle, because that's what I'm trying to model here. And yeah, it doesn't have to be exact, just drawing a diagonal there. From there, I go to dimensions, I go to the angle tool. I click on both the lines, and that will form let's use this. And that will show me the angle between the lines. From there, I could come here and just edit the angle in between those two lines. Afterwards, go back to draw, delete the angle, and delete the bottom line. And I'm going to draw two perpendicular lines, and let me zoom in here for you guys, or for whoever's viewing this. So this was that line I was talking about, and I draw two perpendicular lines coming out from that, and I'll get a little symbol that will tell me that they're perpendicular. After that, dimensions, I come to general, and that's going to give me the length of all of them, from which I could go and edit the length of all three of these sides that I had drawn by this point. Oops. Okay, there we go. From there, go back, once I get them all to my specifications, go back to draw. I'm going to delete these just so I don't overload the program, because like I said, my computer can't handle much. And then I'll draw my last line connecting this point and this point. And because everything else is perpendicular and lined up, I know those are going to be to the specifications that I need, which we could even test out right here. Maybe not. And that's going to be 50 centimeters as well. After that, grab my rectangle tool and just draw a big rectangle to set the boundary, or to set the domain of my flow that I'm modeling. From there, we're going to go to sketch and generate it, which is what gives me this gray box and everything. And I believe that is all I had to do here. So from there, go back to workbench. I'm going to open up my mesh, and of course I've already done that. So let me just run you through the steps that I did here. So first I come to mesh, and I click on the body and hit generate. So maybe that will pop back up, or not, but hit generate, and first I'll get big boxes, and I want something more refined, so I come down to the element size, and here I made it 5 centimeters, or do I have, yeah, so I just made it 0.05, and then generate it again, and that'll give me the smaller boxes. And then from there, I'll right click again, go to insert and refinement. So that's what I did here. For the refinement, you just apply it to the surface body, and then I added up 3 nodes just to make it more accurate. The next step here to do is to click on this edge tool and just go through and name all of the boundaries and edges here. So as you can see, symmetry, that's the top and bottom edge, inlet is the front, outlet is this back wall, and if I zoom in here for you guys, I also did the same for this. So we have the wall in the front, the upper wall, lower wall, and back wall. That's all I really did for the mesh. I don't believe there is anything else to do. So then come back here. We update the mesh, so just right click and click update after we finish that step. Then we go to setup, and setup's going to open up this right here. And here, I'll just run you through all of the things I had done. So general, it's going to load. Oh, there we go. So pretty much anything that was preloaded, I kept standard. Let me just double check this is still recording. Perfect. Everything here I kept pretty standard, pressure-based, absolute, time steady, and 2D planar. Then we go here to models, and we're using the viscous one. The model is going to be K epsilon. We keep this at standard. Near wall treatment, we want enhanced wall treatment, and we want the pressure gradient effects. Nothing else is going to be changed here, so I can get out of this. Next is to go to materials, fluid, air. I don't know if this step is necessary, but I did just in case. Make sure air is selected, change and create. From there, go to the cell zone conditions, fluids, surface body. And from there, we're just going to click OK, make sure the material name is what we're working with. Next is to go to boundary conditions. Click on inlet, edit that, and we're going to switch the velocity to 5 meters per second. And going through here, we have, if we look here, this is the pressure outlet, the symmetry, and then we have the back wall, front wall, lower wall, upper wall, and if you look down here, they're all set as walls because they're all just really boundaries for what I'm modeling the flow around. Finally, go to references. We're just gonna, what we're changing here is our length to what we set it to in the design modeler, and then which is gonna also change the area. Finally, we go to initialization. We could use the hybrid initialization here. But I believe I ran both and I got similar outcomes because I was just testing out the program. So I'm not sure how that differentiates, but I did get similar results for both. We're going to click initialize. Then we're going to go to the run the calculation. I kept it at 500 iterations. Of course, the higher amount of iterations you go, the more accurate of a representation you're going to get. But I wanted to make sure my computer didn't melt. And we're also looking, or the reason for this number is the higher it is, you're going to get convergence some time down the line. So if it takes longer, here I knew it was going to only take about 80 iterations, so I kept it lower, and I probably could have gone lower than this, but just to be safe, I kept it at 500. And then finally, we go back to Workbench after this step, open the results section, and here are the results. So all I did here, once I opened up the program, was click on this top part right here, contour. I'm not going to press OK, but then I press OK when it said contour 1. Come down here, I switch the variable to velocity, location to symmetry 1, number of contours to 50, and then I applied that. And then just as demonstration, I could also switch this to pressure, press apply, and then it will give me the pressure contours here. So I think that's about it for this project. I could also come back to this right here, and I could get my XY plots here. So one of the things we were asked to look for was where the flow separates, and the flow separates whenever we have a shear stress of 0. So we want to set this to wall flexures, X wall shear stress, and the X function is going to be a curve length. Then we're looking at the upper wall because that's where we're looking for the shear stress is 0. Save and plot, and then we'll get a plot here. And here we could kind of just guesstimate. This isn't accurate. The way I was doing it was exporting it to Excel. And then in Excel, I was interpolating to get a more exact value. But just looking here, we could estimate that it is 0 at about this point at 0.002 or at 0.025. But yeah, that's about it. Thank you for watching, and I hope you have a good rest of your day.